All right, good morning, everyone. We're going to go ahead and go over our thermochemistry unit. We're really just going to be continuing what we've discussed in class, but I know there have been some who have been out for testing and various other reasons. So we want to give them the same opportunity to get the material as well as you the opportunity to review if necessary. We're talking about thermochemistry here, which is the study of changes in heat energy that accompany chemical reactions and physical changes. So, if I have a chemical reaction of some sort, one of the things that's always going to happen because I have breaking of bonds and that takes energy, as well as when I form new bonds, that's going to also give me some energy. I have to be able to tell how much it's going to change over a given period of time. The overall learning goal for this unit, students will be able to explain how energy is transferred from one form to another in a system and relate that to temperature changes. Our first section, I guess we'll call it, the learning goal is going to be to differentiate among the different forms of energy. And then we're going to be able to use that information to explain how it goes from one form to another. Not necessarily the mechanism, but the method. So the fact that I can start off with a chemical reaction and somehow end up with thermal energy. How does that process go about? We start our information by looking at the law of conservation of energy. Now, this is a very simple law, but it basically just tells us energy can't be created or destroyed. Whatever energy we have in a system, actually throughout the universe, is constant. All that happens is it gets transferred. So when we look at things like when the sun shines, giving off solar or radiant energy or radiation. If I have a solar panel, then I can take in that energy and then use it to do other things. But if I don't have the system lined up just right, I could end up losing more energy than I want to. Let's take a look at the example here. We have the young lady riding the bike, and notice above it says, "Feed me," which means she's hungry. Usually, most people don't think about it, but when we um, eat food, when we eat our lunch, breakfast, whatever the case, that's being stored as chemical energy. Once we go about our daily activities, like this young lady to ride our bikes, it's then transferred into mechanical energy, some of it given off as thermal energy. It's all going to be used up in some way. Now, in terms of the system, she turns the bike tire, which turns our generator. As the generator turns, that mechanical energy that she provided, it gets turned into electrical energy. And once we go from our electrical energy, that gets turned into thermal energy, which is then going to be released into the environment. I could change this system up in many different ways, but each time we should be able to see how, from beginning to end, we have the energy. There will be some loss to the surroundings, but we're always going to have the same amount of energy overall. So when we sum it all up, we say you can't win, you can only break even when it comes to energy. That means there's no way I can end up with more energy than I started with. I'm always going to end up with the same amount as I began with. Now, nowhere is this more important or more crucial to many of us than when we look at things like our cell phones. We get it out of the box, we charge it right away. Now, we charge up the battery, which is really just adding electrons in order to have a chemical reaction take place. That reaction is taking place inside the battery. But once that chemical reaction is going, it's going to provide energy so that we can do all the things that we love to do. So that we can take pictures, so that we can Snapchat, so we can Instagram, so we can talk to people, so we can listen to music. All of those things are going to expend or use up all of that energy. And then once the energy is used up, we put it back on the charger and do the process all over again. This cycle continues until the battery or the reaction in the battery reaches a point where it will no longer be charged or when it's hit equilibrium and won't allow any more changes. Now, the easiest way for us to determine which way energy is going is to look at what we call the system versus the surroundings. The system is In this case, it's the water molecules in the ice. But in a general sense, when we look at an overall system or overall process, whatever we choose to focus on, that is the system. So if I dissolved sodium chloride in the water, the sodium chloride would actually be the system. But it's what I choose to focus on at that point. Now, the surroundings is everything else. Now, on a test question, I can't just write everything else for surroundings. I have to be specific. So, in the case of what we're seeing here on screen, the cup would be part of the surroundings. The air, if it's sitting on a table or if a person's holding it, all of those things become part of the surroundings. They all interact with the system and give us information about how heat is transferred in or out. I hope that part makes a little sense. Now, we have three types of systems. Oops. We're actually going to go into that in the next part. Look at the different types of systems and how we can use that to look at overall energy transfer. I know the video isn't long, it was not meant to be, so I hope that you will be able to go back, look at the information, and then use it so that you can gain information and gain the knowledge you need for this test. Have a great day. See you all in class.